series of lectures to us, starting one today and another one in the evening today, then the last one tomorrow morning, same time. I will ask my colleague Philip Sherman just to do a short introduction of Stratford. We wanted to reserve it long to us, starting one today and another one in the evening today, the last one tomorrow morning, same time. But over to Philip, we'll ask my colleague Philip Sherman just to do a short introduction of Stratford. We wanted to reserve it long to us, starting one.
Good morning, ladies and gentlemen. And thank you for coming this morning. I would like to introduce Mr. Stratford for a 3-lecture series that we're going to have in the next 3 days. Now, Mr. Stratford is an award-winning architect, designer, and inventor. The past president of SIRE and the 28th Sophia Grade Laureate. Stratford is best known in South Africa for his development of innovative building technology, in particular the award-winning Windblock, the Total Window System. Is a unique multi-skilled impact furniture products which won the designing driver in 20.
Okay, what you see here is a view from a glider cockpit. And I've shown this because it illustrates in some senses how life works. I don't know if you know, but a glider has no engine. It's not powered. And the only power that it has, in fact, is gravity. So when you're flying a glider, you're always flying with the horizon above your level. In other words, you're always falling. So life is like that. Sometimes you're always falling. And what you've got to watch out for when you're piloting a glider is, in fact, you've got to look for the updrafts. And there are updrafts in life. You can look around you, and if you're aware of your situation, you will start to see updrafts in the atmosphere, and you can find that and then start to fly and use that to gain altitude. So it's as long as you are looking out. So to me, life is about being very aware of your circumstances and the situation that you're living in and where you are in society. It's very important to understand that, otherwise you won't understand the updrafts, and you need to find those updrafts as you continue. So I invented the Windblock System back in 1981. And prior to that, I'd been working in Durban, and we had west-facing buildings with windows facing west, and that, as you know, as architects, that's probably the worst orientation you can have, because you get the sun heating up the house or the building the whole day, and then in the evening you get an extra whammy through the west, so you don't want to do that. And so we built, about a meter away from the building, we built these screens, concrete block screens, in fact clay block as well. And in that way we were able to shade the western facades. And on the back of that, I then went to East London in 1981, and I developed the Windblock window, which is in fact a precast concrete window, and into which you can glaze. So I combined the external screen with the window and made it into one element. And there you can see it in section. So it's a precast element, about 600 by 600, in fact 590 by 590 with a 10 joint gives you a 600 module. And it is designed to be glazed on the one facade. You'll see this edge here, it has a rebate. There's also reasons for these rebates on the outside face. and we're able to glaze directly into that face. There you can see the glazing plane added, and then the opening window. So to use conventional aluminium extrusions, they were far too big for this little window. So I was able to design my own extrusion. So that was the next bit of industrial design, extrusions in red. And you'll notice that they are identical. So the window is normally made up of an external frame and an opening sash. And so very often those are two different extrusions. And I was able to eliminate all the different extrusions by coming up with one, what we call universal extrusion. And the fundamental thing is it has a flange there. And that same flange can receive the glass or be fitted into the concrete woodblock. We glue it in. So the grey there is a silicon seam. Back in '82, Helmut Jahn was doing Diagonal Street in Johannesburg and 320 West Street in Durban. And for the first time, they were flush glazing buildings by gluing the glass onto the structure. And so I was very quick to pick up on the use of structural silicon to bond these windows into the concrete. And in that way, we were able to provide a solution out in the marketplace. So that one extrusion then became a universal extrusion, and with that same extrusion we were able to make central pivot windows, a top lung opening out, a bottom opening in, using the same extrusion throughout. This is basically the graphic, it's part of the graphic that we used to launch Windblock back in 1984, Christmas '84. I put it out into the market, and the phone started to ring from all over South Africa, up in Namibia, Polokwane, all over South Africa. Architects wanted this new product, and so I had a business which was a tiger by the tail. It's very hard to handle a business that grows too quickly because you need cash to make it grow. You've got to buy more product to manufacture to push through. And so I had a tiger by the tail. And architects started using it throughout South Africa. This is a building done by Luigi Ferreira da Silva. He's a good Portuguese guy that came out of Mozambique. And you can see the colors there. And he in fact put that whole Windblock screen into the wall. You'll notice that there's a periphery edge there. It doesn't touch the brickwork. In fact, it had a separate piece of glazing. So in a sense, he framed that thing as a separate unit within the structure. Not quite the conventional way of using it. This is in a project up in Botswana where it's used in the post office. And what you get with the Windblock is a lot of bounce light off of the deep reveals. And so it helps to diffuse the light and bounce it into the building. In that way, it's actually also a structural element, but at the same time bouncing the light and shading out direct light into the building, which is quite important. So back then we didn't speak of green technology, we spoke of appropriate technology. So everything that we tried to do was appropriate to the circumstances. I think you understand that. So it's the same sort of thing as green technology that we do nowadays. So these sunscreen grills, we integrated them into a modular window system. The next product that I developed was what we call Windstep. And staircases are quite difficult things to handle. They are focal points in buildings. They transition between up and down. And they often need lots of shuttering, a lot of working out. So I developed a system which basically has pre-stressed concrete beams with scallops on the top of them. And the treads have a matching scallop underside. And we can then change the angle on this to make flat bridges or ramps or in fact staircases. So using basically two precast elements, one is the tread and the other one is the pre-stressed beam. We're able to make staircases. There you see it in a ramp format, the top drawing, a ramp format, and then this is in the staircase format. There you can see some applications of it being used. So how did I get the idea? How did I actually get that idea? And this is a drawing of something that I saw in an Archie magazine. good to look and learn. You must always look at everything that you can. And somehow or other, in retrospect, I realized that the lights, the pendant light fittings above that staircase, that somehow that triggered in the back of my mind that solution. Can you believe that? I think it's very interesting to know how your brain works. It's an amazing thing, and when you sleep at night, things start to go. And I hadn't actually come up with that idea. I didn't know how I came up with it. Then it clicked. And I suddenly realized that, hey, I'd seen this picture. I looked for that magazine, I couldn't find it. And so I redrew it just to illustrate the point there. The next product that I did was Winddeck, and that's a precast concrete lightweight flooring system where we use pre-stressed beams. And if you look at these beams, they're full of holes. Why do we put holes in them? To get rid of the mass, get rid of concrete, get rid of costs. And you don't need strength in the middle of a beam. You just need to make sure that the bottom and the top are in fact related to each other and don't shear. And so by putting holes through the product, we were able to reduce the mass considerably. And then we simply lay those beams, and then the floor tiles go on top. And that the floor tiles can be pigmented, and so you have then a system with a lightweight floor. Conventional floor that spans 6 meters will weigh around about 480 kilograms a square meter. This weighs 180. So there's a radical reduction in the amount of material and still being the same load capacity. In 1999, I designed and built this guest house. This is the photograph of it. And I got this photograph because the South African Air Force came to stay at my guest house. And they were a helicopter squadron. And when I was in the Air Force back in 70, whenever it was, 67, 68, a helicopter had gone into the sea and killed the crew because they couldn't get out of the helicopter fast enough. And so I was in a drawing office down at Easter Plant, and they asked me to design a testing or a rig to drop the pilots and the crew into the harbour. So I made a little frame out of aluminium rod, in fact welding rod, and masking tape. And I said, that's what we want to do, and they built this thing. So when these guys arrived, I told them the story. They said, what? Are you responsible for dunking us in the cold Simonstown water? But they gave me then a nice flight, and if you are in the military, you can fly below 3,000 feet above the ground. So you're able to fly low, and we flew over and took the photograph of this. So just to illustrate this to you, this is the street called Frere. This is the house that I built with Windblock back in 1980 when I invented the product. So that's the first Windblock house. There was another house in front which I bought, and then I built this whole new building. And this is the major one, and there's a minor one there. So they're very different in their way. That is due north in that direction there. And the weather comes from this side, so for the architectural students, the weather is from this side. So this building offered its back to the weather, and it created a courtyard space. If you look over on this side here, there's a whole lot of townhouses which had their lounges facing due south, looking into my garden. And so I built this little building as a wall, as a protection for an internalized court. And in that way we resolved the whole architecture of the building. You'll notice that there are slots on this face here. So what I did was I used corrugated iron, corrugated steel, and we bent it. So if you bend something, it actually becomes stronger. It acts as an arch. If you attach a piece of corrugated iron there and there, and it wouldn't bounce, it does that decay. But if you bend it and you attach it, it's arching. So by flexing it across the structure, we were able to arch it. So using engineering principles, able to produce a very lightweight wall on the south facade of this building, which was also a cantilever. So I reduced the mass of the load on the cantilever in designing this building. So there you can see the cantilever. We needed to set the columns well back so the cars can reverse and come out of there. And so that cantilever is 3.6 meters at that point. And by Using a lightweight walling system, we were able to reduce the load on that. Cantilever, another word for cantilever is a hangover. You know what a hangover does to you, eh? It's not a nice thing to have. So to avoid a hangover at all times is best from an engineering point of view, and also from a life point of view as well. Try and avoid it. So to reduce the load, we use the structure. So it's attached here, it's attached at that line there, it's attached up at the roof. So this is me wearing the trainer office, and that's my beautiful wife, back in 2009 and 2010. This is another view of something that I developed. You'll see this is glass here, and it's actually bent. How do you bend glass? You heat it and you bend it, that's one way to do it. Another way is to toughen glass. I don't know if you know what toughened glass is, but basically you take glass and you heat it up to almost melting point, and then you suddenly freeze it. So by freezing it, what it does is it puts a tension in the outside skin of the glass, and that glass won't break. It's like the side windows in your motor car. When it does break, it's tiny little pieces. You might have seen that. It's trying to think of the word they use. Can't think of the word that they actually use for it, but the same technology has been used quite extensively in Europe. This is a building that I did for a housing association. It's called the Van Strien Plaza. It's supposed to be surrounded by buildings. Any plaza is surrounded by buildings. And I said to them, guys, don't build this until you put buildings around it. Because a plaza is not just an open piece of land in the veld. But Mr. Van Strien, who was funding it, wanted the building to be built. So we went ahead and built it. And I built it, I'm going to go back to that. I built it with a team of local guys, just hands-on, actually building it all with timber. And we did all the components in the factory, hot dip galvanized, and the poles and things we just simply buried in the ground and then assembled the whole building. I'll show you some more of this in the other presentations that I've done. Cold bending of glass is the term I was looking for, okay? So you don't have to heat it up, it is in fact cold bending. And this is a little building that my eldest son, by the way, is an architect, and he studied at NMU under Professor Donnie Turon, late Professor Donnie Turon. This is a building that was built on top of a 9-meter diameter water tank. And so it's a circular building, and we bent the glass on timber frames to achieve this. And it's a double layer of glass, and we bonded onto the glass different colors sand. So you'll see this black look, that comes from titanium. On the beaches down where I live, on the Eastern Cape, we actually get black sand on top of these sand. It's beautiful stuff. It's absolutely black. And we bonded it to the glass so that you get different colors within the building, looking at this from the inside. In 2009 and 2010, I did this building for the University of Port Hare in East London. And it is a 6-story building. We had to achieve maximum air changes in the spaces. Basically, you have to have any auditorium like this, you've got to have 3 air changes per hour. Otherwise, everybody starts to fall asleep. Okay, so you want to keep the oxygen flowing. And so I used the whole building to, in fact, be a generator of the airflow. And this is the external shot of it. Here's an internal cross section. This is an enlarged example of the wind deck floor. We had to span 8.4 meters. And 8.4 meters gave us 3 parking bays. So we were able to use the parking bays under the building to generate the structure and span that with this floor. On this side of the building, we brought the air in, and we took it out through this. And this is a venturi. I don't know if you know what a venturi is. If you do any mechanical design, if you constrict the flow of air, it speeds up, and when it speeds up, it actually uses pressure. And that's how an aircraft wing works. So with any wind going through under that, we were able to then reduce the pressure and draw air. There's a continuous slot at that point there in each level. by doing this building, I was able to reduce the carbon footprint by 33%. I don't know if you know, but for every 50 kilograms bag of cement that we produce, we put 50 kilograms of CO2 into that. Cement is terrible stuff from a green point of view. So we need to move away from concrete, which is my life, and I'm moving away from it. I'll tell you about that as we go forward. So I was able to, by using very high strength concrete and pre-stressing, reduce the cement content by 48% in that building. There's a lot less concrete in the building. Okay, a lot less cement. It was 41% lighter. What that does is it reduces the loads in the columns, it reduces the foundations, and that way you reduce all the concrete and the cement in the building. And we were able to be cheaper as well by 11%. So that's a view of the building. So what we have in these spaces are big precast concrete elements that stand like that, and they face north, and they are black, pigmented the concrete black. And so the sun coming in on that facade was able to generate heat. So we had, for instance, in the middle of winter, 17 degrees outside and 35 degrees in there. So that difference in heat created an updraft in the building. So we were able to evacuate the air through the building. More recently, I've done Windblock, which is a new product, and it is a passive sun control facade system. And basically what we have is a pre-stressed concrete, very thin sections. There's a thermal barrier at that point there to stop the heat going through, and that provides shading, as you can see on the floor there. Depending on the sun angle, you can provide shading to the inlet. Doing furniture is all about connections and how do you fit it together, how do you bring it together in proportions. And so by taking 2 sheets of plywood and putting a fabric in between and then scoring it, if you've made models for architecture and you want to get a curve, you simply score it and you can bend it. Okay, so we scored it with a CNC machine and then filled that with a flexible rubber. So in that way, you can see how we bend. You can bend this in both directions. It becomes very flexible. So that was me getting the award at Design Development 2013, and there you'll see some of the furniture that we produced doing that. So it has a rigid frame, but all of this is flexible. It's actually a flat pack product, and one can assemble that straight out of the box. Using a CNC machine, cutting very accurately that puzzle piece there, able then to fit the parts together, and using Allen keys to hold it together. So these are some of the different prototypes done in cardboard, and just working with models and full-scale prototypes. So a lot of energy went into the Stratford furniture. I must say it wasn't successful. Okay? It hasn't made me money. All the money I make, I spend on my next idea. Okay, you have to be careful when you come up with new ideas, because what does the market do? And so how do you market products becomes a very important thing. So I'm going to basically just carry on now. I'm going to exit this, and then I'm going to go to Okay, what is intellectual property? It's the property that you generate through your mind, okay? And how do you protect that? I want to talk about that now. And so my whole life, I've actually made money through investing in intellectual property, which is basically your own time and your own energy to come up with ideas and then protect them from other people using them. And how do you do that? I'll talk about it. So intellectual property is part of Western capitalism. And perhaps I can explain that to you. Capitalism is based on the fact that property can be protected by the state. And there's basically three types of intellectual property that can be protected by the state. And the one is intellectual property, which is ideas of the mind. The other one is company shares of things. You might have share certificates. The state protects that. And the other one is title deeds of property. So those are very important aspects of the Western system. However, capitalism, as we know, has become a rather difficult thing to handle globally. Because what happens is the rich get richer and the poor get poorer. And that is a negative. And so 2008 saw, in a sense, the turning point when we had the crash in capitalism. So the background to that is that I think that to a large extent we have to be very careful of intellectual property as being the thing that you trade with, because it can be stolen quite easily. Okay, or for instance, the state could possess your piece of property, and then you no longer can have what is called a fungible asset. Let me explain that to you. Basically, if you have a piece of property, you have a title deed. It's a piece of paper which you can trade with. So for me to build that guest house in East London, I had a title deed. When I went to the bank and I said, "Here's my title deed," and they said, "Okay, we'll keep your title deed and lend you money. And when you pay us back, we'll give you back the title deed." And that way you're able to borrow money. And so if the state doesn't protect that, then you have a collapse of the capitalistic system, because the banks won't lend you money. I live at the very eastern part of South Africa. I live at the end of the Cape Colony and the beginning of Africa. Can I explain that to you? I live in East London. That's where the Cape Colony ended. And the colonial people never crossed over the Kai River into the Transkei, as we call it. And I can cross over that river and see people building beautiful houses, but they don't have access to finance. They build it out of cash. And that is how they're able to build, just by taking cash and building. So the houses are then incrementally built, they're not built in one shot. I experienced that when I went to Brazil in '93. Very interesting to see half-completed buildings all over, because they were building with cash. They couldn't actually borrow for similar reasons. There wasn't protection of the of the asset, of the property asset by title deed. So we have a different situation here in South Africa. And I'm just going to talk to you about the source for my understanding of this was from a book written by Leonardo de Soto, The Mystery of Capital, and why capitalism triumphs in the West and fails everywhere else. And he says basically because the West has taken the capitalistic system and put it into the legal part of the country, it is then adequately protected by the state. But if the state doesn't protect it, as happened in Zimbabwe, then you get a situation where suddenly the whole financial situation collapses. And that happens in countries where they don't protect the intellectual property. Now, China is perhaps one of the best known countries for taking intellectual property and using it, okay? And so you can get copies of things done in China very easily. So if you want to market in China, how do you do that? It's not easy, okay, using intellectual property. So with my furniture, I went to Jakarta, which is in Indonesia, and I went to a furniture fair. I saw how most of the furniture that we have in South Africa is actually produced in Indonesia and China. And what you would buy there for 1,000 rand there, you would pay 5,000 rand here. Okay, so they actually are able to produce very, very cost effectively. So what has happened, and I met some of these guys, people from Europe are going across to Indonesia and marrying Indonesian girls that way they're able to set up their own production. And I heard about one guy who came back from Germany and he was locked out because his wife now knew how the whole thing works and didn't need him anymore. And so they continued to produce the furniture. So I had some very rude awakening in terms of how the furniture business works globally. When I won that award, I had a response from around the world. We weren't able to step up to the plate quickly enough to actually capitalize on that production, the logistics of getting exported. It's a whole thing to handle. So the whole chain of thing in terms of industrial design is a very important thing. When you design something, how does it actually go from your design to the point of sale? And who buys it? And how do they get it? How do you produce it? How do you export it? And so on. So it's quite an interesting thing that you set up with, that you battle with. So one of the chapters in Ronaldo's book is Listen to the Barking Dogs. And he says that the dogs know where the boundaries are when you go into the township. And I think that's true. And then you stick in pegs and you put GIS onto that, and then you can define the property and set up individual title deed. That hasn't happened. So it's not that let's put it this way, it's not that the Western world is not trading, it's just not building, it is building. It's doing things, but it isn't able to trade with them. So if I have an American that wants to buy a house in the Transkei, he's got to negotiate with the headman around the corner to make sure that he actually can own that piece of ground. And he's not going to do that, so he's not going to do it. So you can't trade with that property. I in fact have a cottage on the Wild Coast, and that was built by my wife's uncle in 1953. And he has what is called a PTO, permission to occupy. And that document says that if the state wants that piece of ground back, they can give us £1,000. It used to be pounds in South Africa before the rand. In 1953, they can give us £1,000 and take back that cottage. Which means that we don't spend money on that cottage, because the day could come and they say, "Yeah, full left, you want it." And then you talk, "Yeah, this is close on that." Okay, you might understand what I'm saying. Okay, so this whole thing of intellectual property is very important to understand if you're going to trade with it. And how do you manage it? Patents have a 20-year legal monopoly. So if you come up with a patented idea, nobody else can use it for 20 years. But you can use it and allow other people to use it. In fact, in the Patents Act, if you don't allow other people to use your patent, you can in fact be struck off the roll. You can lose the patent, because you can't sit on a patent and hold it down. That's very important to know, because then you're being unfair to the rest of society. You come up with an idea that you're not allowing. I think this is happening now in open source IT. There's a lot of stuff out there that is open source, and so the way in which we can open source things starts to in fact grease the wheels and make the world work in a better way. So the 20-year monopoly can be short-lived, and then you've got to have very deep pockets. So the people that get involved with this type of thing are the big companies like Apple and Microsoft, and you've got to have a tremendous amount of capital behind you to be a capitalist. Okay, I think that's the one line. Registered designs are another way, and you get two types here in South Africa: the aesthetic. What does it look like? And then you get functional. So, in fact, aluminum extrusions, it's not about the aesthetic, it's about how it actually works. So, if you design an aluminum extrusion, you can register the design. It has a 10-year protection, so nobody else can copy your extrusion. And then you have copyright. You might be aware of that. If you write a book or something, or do a drawing or a piece of painting, you have copyright. That is, you've got to make sure that you are the authentic, original owner of that, and that protects you as well in terms of books and things, and software as well, protected by copyright. But I want to speak about trademarks. So if you spend money on a patent, you have 20 years. Within 20 years, your money is gone. Okay, but you've had 20 years monopoly to try and get the market going. If you take a trademark you can keep forever, as long as you keep on trading well. So if you, for instance, come up with a nice thing called Coca-Cola, and you call it Coca-Cola, and you register the trademark, and you do well with that, then everybody in the world knows what a Coca-Cola is. And people can't copy it, so you have Pepsi or some other name, you can't use the name Coca-Cola. So trademarks have a long life. You have to renew them every 10 years, you pay a little bit of money in just to make sure they keep going. But your trademarks give you their protection for a very long time. So there's a sense in which the money spent on a trademark, if you trade well, it actually gets more and more valuable. So if you wanted to buy the Coca-Cola brand, you'd have to be very, very rich because it trades globally with that trademark. So I've started to focus more on trademarks than on patents and things. So I think that's the better route to go. We also have trade secrets. In fact, Coca-Cola had a trade secret. Nobody could copy how they made it for a long, long time. That's something that's not registered. That's something you do as a company. You have a sign on the door that says you can't enter here. So you can't see what we put in. And you've got to be careful that they don't hack your software and find what you do. And so you can have trade secrets to protect what you've got. It's another way of protecting your intellectual property. So how do you trade it? You can franchise with it. I've done that before. That's one way of actually trading with your ideas. You can sell license if you have registered trademarks. You can go to somebody who wants to buy it, you can sell the license, and that means they can then manufacture it using your trademark or your patents. I'm going to go into, hopefully I can pick up on the internet here now. It's going to be a question. I could do it through my cell phone, right? The least it's not through my cell phone. It's probably the easiest. So this is our web page, Windblock Innovation. And I'm going to speak about architectural systems first of all. And this is the Windblock one, and then this is a new product that we're putting out right now. And I can give you some background as to how we're doing that. I'll show you. There we go. So that's the original Windblock system, which I'll just click into. That's a bit more conservative, and there you see it uses clear story with the central pivot windows. This is my own guest house, but I've used it continuously along the one facade. These are just so this is the new product that we're busy developing right now. We're putting screens over the face of Windblock. I'm calling it the great cover-up, okay? And we're doing what we're calling a squircle. It's a square circle. Okay, and then the nest and the louver, these are solid panels which we can actually put onto the face of the Windblock to make a continuous wall out of it. Walls you can see through. Essentially, a Windblock is not just a window, it's actually a wall, it's a load-bearing wall. And we can test it CSR to make sure that you carry the load. It's a load-bearing wall up to 40 kilonewtons per linear meter. So a double-story classroom, for instance, can have continuous walls of Windblock carrying the first floor and the roof, all that load coming down. So these are the new louver panels. This is the squircle. You see it there. And this is the nest, as we call it. This is on the Beijing bird's nest, Beijing Olympic building, as a precedent. Louver screen, solid panels in plain, and then in the shutter timber textured ones. So these are new products that we're busy rolling out right now. So Moontek Innovation, I come up with the new ideas. I have an architectural technologist. We do this in 3D, and then my graphics guy starts to do these lovely presentations. We haven't made the product yet, so it's pretty early. Still at it, we're selling it before we make it. That's how business works. So you hope you can make it. Yeah. In fact, so to make it. So just to give you an understanding of how we make a product like this, if you take those elements there, that element there, we make with a CNC machine out of MDF. You know what MDF is? Medium density fiberboard, also called superwood inside. So we cut that out very neatly, exact product as we want it. We then seal it off, so that, and then we coat it with a wax. We pour a urethane mold around that, and we put that urethane mold into a steel tray, and then we pour concrete into that mold. So it's a multiple sort of process, and then you can make more urethane molds to up your production. There's basically two ways in which concrete is, actually three ways in which concrete is managed. Concrete, has anybody got some water for me? Is that a possibility? So concrete is basically a mixture of cement, water, and what we call aggregate, which is sandstone and smaller bits of gravel or whatever. And the strength of concrete lies in the water to cement ratio. If you have too much water, you water down the cement, you have to add more cement, it gets more expensive. And there's two reasons you put water in. One is for the chemical reaction of the cement, the other one is to make the concrete workable so it can flow and go into a mold. And we always want concrete nice and wet, do we? That's the wrong way to go, but it's easy to work with, especially if you're hand mixing it. It's not easy to mix by hand or to put into molds, so we tend to make it too wet, and then it gets too weak, you have to add some more cement. The other way is where you make a very dry mix, and you put it into a mold and you compact it and you push it out. That's how they make concrete blocks. With those dry mixes, there's not enough cement in there, so it's actually called a breeze block. The wind almost blows through it sometimes, and water penetrates through it because there's not enough cement to close up all the cavities within the concrete. So that's the second way. The third way is what they call vacuum dewatering, where they put lots of water in, then they suck out the water through a filter. So the water comes out pretty clean, leaves the cement behind, and that is vacuum dewatering. So those are the three ways. But whichever way you go, if you need a lot of products, if you have a mold, if you need 1,000 components a day, you need 1,000 molds. And 1,000 molds will cost you a lot more than a machine that could make 1,000 in a day. So sometimes the machine is the cheaper route to go. But you might have to pay R500,000 for your machine, or perhaps even 5 million rand for your machine, whereas your mold might only cost you 5,000 rand. So you can start off small with molds, but once you get volume, then you need to change the machine. So when do you change? So that's quite good. Thanks very much for doing that. Thank you. So this is the process that we use. You can see these are rather thin. Once again, very high strength concrete. You have to reinforce it to make sure that you keep loading. Go to the Windblock system, also the pre-stressed concrete blades. So it's a complete solution. Concrete blades, the glass, the opening windows. It provides a sill, it provides a lintel. It's actually a louver at the same time. So at one stage I had a guy that worked with me. He was in fact an industrial designer. He said, you're trying to design a toothbrush that you can comb your hair with and polish your shoes. Okay? You've got to be careful. You can try and do too much. And none of them actually work. Okay? You don't want to polish your teeth or in your hair. So how do you actually, in your design process, how do you actually find the balance between having one thing that actually solves many problems? But the less components you can do, the better you can actually have the production process become far more achievable with less components. Bounce light and interior climate control. These are some of the examples. This is a studio, an artist studio. It's completely surrounded, so there's a lot of light coming into that building. This is where we've put an opening window in, and we're bonding the glass directly in. This is up at Cullinan here. We did a library up there. This is a house down in the Western Cape. And that's the house. And this is a house in Durban. Here you'll see we have a column there which takes the load. You can see it over there, and we're able to go around the corner. So it opens up the corner of the building. And then the opening windows and the glass directly bonded into. So the process of production here is pre-stressing. Now, pre-stressed concrete is a way to make concrete very strong without a lot of reinforcing. So what you do is you have a mold and you take high tensile wire and you pull it in the mold, you stretch it. And so on a mold, say 9 meters long, we'll be stretching it as much as 150, maybe even 200 millimeters. That's a long way to stretch a piece of wire. It's very tough, it's like your guitar strings. It's very hard wire. Normal steel is around about 400 MPa, this is 1,800 MPa. Very hard tensile wire. Because it has a high chrome content, it doesn't rust, so you don't battle them with sprawling, which is when the rebar rusts in concrete. So you're able to eliminate sprawling. So you stretch the wire, you cast your concrete around it. And when your concrete is up to a particular strength, you can let that wire go. If you let it go too soon, it actually breaks the concrete. Because it's shrinking, it just pulls the concrete and breaks the whole thing. Get up to strength. So basically, we have to have 25 MPa before we can change it, take it out the mold. So that's quite a thing to do. You get 25 MPa within 3 days. Normally, you speak about 25 MPa in 28 days. But we have to do it very quickly, otherwise that product stays in the mold for far too long. You'd have to have a lot more molds than you're able to make the product to meet the demand. So how you actually produce it, how you get your concrete strengths are very important. So I've had to learn a lot about concrete and how quickly you can get it to set. Then its final strength will be around about 50, 60 MPa. Very, very strong concrete. There you can see it's in a building. So it has its own particular aesthetic, as you can see. And sometimes this doesn't work for an architect. It doesn't go with what he's wanting to do. But sometimes it does, depending on what he's doing. Okay, so it's that type of thing. It's very much an architectural product as well. And so those are the basic components. You can see when it's laid parallel to the beam, you end up with a ramp or a flat bridge. And when you rotate it even further, you need to then put them at a spirit level and glue them in directly into the concrete. It's glued in. And you might know the ratio of riser to tread. The maximum riser is 200 with a minimum tread of 250. And so this, the whole maximum we can do is the 200 rise at 250 thread. The only fixed dimension of this thing is in fact the distance apart of these scallops. So that is how we actually regulate it by setting the diagonal. So as you change the diagonal, the riser and your the other two sides of the triangle change as you change the angle. Take you to Stratford just to get a bit of a view of that. So that gives you a soft seat as well. So able to flex. Those are some of the dimensions. So these are two young guys that happen to be my sons. They are sending, that's the flat pack format of it, all flat in a box. Sending it using Allen keys. So Andrew is on the network and we look at Andrew. So if you do any furniture design, it's all about connections. How you actually put things together. You can see that that is flexible. I've had a bit of practice, so perhaps a bit quicker. You know, when you buy something from game and try to use the instruction, it doesn't work so easy. The CNC machines cut very accurately down to 0.1 of a millimeter, so you can actually know the tolerances very accurately. I'm not going to go into any other videos. Let me take you back to where I'm talking. Yeah, I think that's back to there. And yeah, I think I'll actually go out of this now. And I'll get back to the slideshow. Okay, I'll end there. Thank you very much.
It was Stratford, I think, as a school, I gave all the background